Okay, we have everybody who want to come today. We'll get started, okay? But before we get started, let me actually emphasize one more time. Some of you last year worked on the HTML, CSS, JavaScript, and Python, okay? And that's for data processing and data science and APCSP, okay? And this year you work on the APCSA for Java, okay? So these two courses are quite different. This APCSS course will prepare you for the problem solving and competitive programming. So this C plus+ and Java is one group of the course. You learn first to learn the Java language. Then we work on the coding bed for the basic algorithms. So basic loop, basic string, basic logic, basic recursion, basic map, basic usage of the programming structures. Then you move on to competitive programming, that is user code. Then you practice the leak code, practice the hacker rank, practice code force, practice user code course. So that's problem solving. So this actually is a route you need to go through. Okay. So this year is very, very important, very, very important. Probably the most important part of whether you can go into CS or not. So this course is right here. A lot of possibility is out of this point. Okay. So that's why I keep emphasizing this course. Try not to skip course. Okay. Some of you keep skipping courses, join a lot of useless activity. I don't know what they are. If you are computer science major, you don't need that, okay? Your top priority is programming. Go back to your fundamental, okay? That's the first thing you need to do. And then this course will enable you for many other activities later. But if you fail in APCSA or you do not do well in APCSA, whatever here is impossible, okay? So you are basically impossible to move on. And then the APCSP basically is building your knowledge in Python and HTML. So you move on to math, move on to data science, move on to website design, move on to database, move on to website design. And then this is to design the software, to understand what is the software, and then to develop a website, develop a software. So problem solving and software engineering, these are totally two different disciplines. Okay, so this part is AP, CSP, and website design. This part is AP CSA for algorithms. These two, you both need them, and you can take the AP CSP first and then CSA, and or AP CSA first and then CSP. It doesn't matter, okay, which way is, either way is okay. So for us, we offer you 3-year curriculum, 1 year in CSP, 1 year in Java, 1 year in C++. Okay, that's our standard education here. And hope you right now focus 100% on solo learn, then coding that, then user code. Okay, this path is what you are trying to go through. Okay, once you go through this path, the next step, you will go to college. When you go to college, that's when that you go to Berkeley. That's as soon that you are lucky you get into the Berkeley. So you will have introduction to computer science for CS foundations, like including programming language, data structure, and machine structure. Okay, these are a introduction to CS in college level. So this one is AP, actually computer science foundation. And then you also have the EE foundation, electrical engineering foundation, that including machine learning, discrete math, and also here also have physics 7B for electromagnetics. So you actually learn the circuit design and also the programming both in Berkeley. Okay, Berkeley East major. So your APCSA is connecting to here, to these three cores. Okay, to these three cores. And your math and physics connecting to here, to EE major. Okay, so these are something needed. And later you move on to AI track. You will learn more math courses, artificial intelligence, machine learning, robotics, DSP, signal processing. These are the Berkeley related AI courses. Okay, whatever. These are too much. Anyway, we are preparing you for the foundation for CS, and hopefully if you like CS, you have to put this on top priority right now. Okay, don't just try to meet the minimum requirement. That's actually not enough. So what you need to do is that every week we give you the lecture, and each lecture we have examples. So after class, you need to review the video and also rewrite the program that we have in the class, making sure that you really understand those programs, and also you can recreate those programs by yourself, making sure that you pick up those topic and knowledge and later become your own knowledge, and you can do similar programming. Okay, that's the goal. And then on Monday, Thursday, or Friday, you join the coding practice. We give you from the language basic, that's a solo learn, make sure that you know about the language. Then we move on to the program structures on the coding back to the if then else structure, for loop functions, and also the recursive function programming, and also map data structure. Those program structures are the second level. Then we move on to third level, problem solving in user code and data structure. Okay, and that's later. That's actually our next goal after APCSA. Okay, but if you fail in APCSA or you cannot follow, then you cannot move on. Okay, that's very you will have to be responsible for yourself. Okay, don't miss class too often. Okay, anyway, let's go back to our material. Today we move on to chapter 4, application programming interfaces. So application programming interfaces, sometimes also called library. Library are something that have code that people already written for you. Okay. So if you want to search the internet, you can search Java API, okay, Java API, and search for the image. So here you will see some Java API. Let me see Java API. Java API including Java program, Java compiler, Java API, Java virtual machine. So you basically working on Java API with your Java virtual machine. Okay. So Java advantage of API including these. It gives you the different support library, IO support, every support for you. Okay, database, all kind of support. And these are Java API, Open Java API, internal API, whatever. These are different API. So API is a library. That's actually try to use another name. That's called Java JDK. Okay, Java Development Kit. Okay, let's look at this one. So Java Development Kit, including Java Development Kit, Java Real-Time Environment, and Java Virtual Machine. Okay, these three different parts. So the program that run your program is called Java Virtual Machine. Okay. And your library, your scanner, your utility, those kind of things is Java real-time environment. Okay. And you have Java Development Kit, that's a Java compiler, Java DAC, Java jar, Java Virtual Machine. These are Java Development Kit. So these three together is called a Java JDK. Okay, Java Development Kit. And then Java JDK support all kind of different software companies. Okay, and Java JDK, let's actually look at, they are in real-time environment. Let's see. Actually, let's see. Okay, this one. Okay, this one actually is the software you download, including Java JDK, Java JRE, Java API. Okay, these different things, where they are. Okay, you can go to your programs, your C drive, your program files, and then go to Java, your JDK 1.8 something here. Okay, and here you have bin, binary code library. So under the library here, you have Java version with several libraries. Okay, moving up, they are bin, they are includes. Okay, include, they are different includes, and they are bin binary code. So here you have different kind of the program and library. So right here you do have, let's see, you do have Java shell. You do have Java, C, Java, and Java shell. Okay, let's move on a little bit. Okay, here is Java and Java C. These are different programs that provide a service for you. Okay, these are different programs. So it's a Java, Java C. These are the development kit. Okay, so you basically using the compiler of the Java C, and then you run it using Java virtual machine. That's Java. Okay, and then you also have some library like graphic library like Swing. These are graphic interface. Okay, later we may teach you these. Okay, sometime we may teach you these. Mathematical library. Okay, these are the real-time environment. These are part of the API. So API is tested in AP. Okay, this AP exam will test it. So you need to learn the math collections. Okay, there are too many. Okay, but basically these are different kind of the library that you have. So today we do not want to go everything. We just give you some basic ones, maybe just math, maybe just some utility. Input methods. Maybe these are all we cover today for the API. Okay, but in reality, this API is much bigger. Okay, any questions so far? So we are going to talk about the library, but it's actually only part of the library, including the AI, I/O, and different things, but only part of it. Any questions so far?
No.
So
No.
we will cover different rebel class methods and math class and API libraries. Okay, these are the goal. Okay, here you see that's a T something. This different T something is the topic of the new course curriculum. Okay, the new 2026 AP Computer Science A curriculum requirement. Okay, so we will cover the different rebel classes and the math class and API library. So first, let's go to the Boolean type. Okay, Boolean type. For Boolean, Boolean has a Boolean class and the Boolean type. Okay, so Boolean type is by itself. Boolean type is primitive type. Okay, so it only true or false. Used for logic. And we also talk about we may have strings. So string is a character. Okay, and then we have character class and we have string class. And then on top of it, there's a string builder and string buffer. So these are a series of the text-related classes. So these are numbers, logics. I'm sorry. This is text. Number are here. Okay, number are here. So number, you have integer double short long, and then they have wrapper class integer double, and then mass class. Okay, so mass class, string class, Boolean class, character class, they are different classes that provide a service routine to help to do the programming. Okay, we'll talk about it. But right now, just remember that this API at this moment, what we cover is number, logic, and text. Let's move on, okay? Let's move on. There's quite many things we need to cover today. Okay, so logic, you have true and false. That's easy, okay? That's actually fine, easy. So Boolean value, you declare Boolean as B equals 1 greater than 2. 1 greater than 2 is false. So B is a Boolean variable that will be stored a false in there. Okay, a false will be stored in B variable there. And then each one of these Boolean operator will perform the computation, but they will give you either true or false. So these are easy. But the mathematical symbol is like this. Don't write in this way. Don't write A less than equal to. Okay, this is wrong in Java. Java, you have to write less than equal. Okay. Okay, these are terms that you need to know. This portion, I think, is easy. Okay, next one is you have Java expression. If you have A greater than 3, this is an expression. Okay. So the expression will return you some Boolean value, true or false. Then you may also have function. Okay, function may also be Boolean function. So Boolean function is a function that return true or false. So character class is later, C later. Okay, this will check is this a C is a later or not. And it is a later, so this one will return true. Character that is later 5 is a character, but it's not a later, but this one will return false. Okay. And here, this one, character that means it's a class method. Okay, it's a class method. Let's look at class method. Okay, we are talking about method. Let's talk about class method. So let's create something called point. So point is a class, right? And last time we talked about class may have data class, may have program class. Okay, so let's assume that point is a data class that we actually developed last time. So it has integer x and integer y. Okay, and you have the constructor of the point and integer x, integer y. Okay, and then you can initialize these two variables. So this dot x equals x, this dot y equals y. Okay, and then you do public toString. Okay, so this one give you a class. This is a pure data class. So this pure data class, there is no static function, no static, none of these words static show up. So everything belong to this class, belong to the object. Okay. So this program you can compile, but there is no main program. You cannot run it. You cannot run it because it's pure data class. There's nowhere you can run it. Okay, so then you need to create a new class. Let's call it test point. So test point will have the main program. It's a driver class. Okay, last time we talked about this already. So let's do import java.util. So this util is from the utility library. I'm sorry. From the utility library. Okay, utility library. Okay. Yeah, all the IO functions are in there. Okay. So that's the utility function. And in fact, what we want is the scanner. Okay, but here I put a star. Star means everything. Okay, star means wildcard. So star is wildcard for everything. Okay. Then we have this test program. This test program will have main program to test the point. Point is a data class. There's no main program, but here we do want to have a main program. So public static void main string bracket args. So here we create a point p1 equals to 3, 4. Okay. And then point p2 equals to point p2, 5. Okay, and then system.out.print line of your p1 and system.out.print line of your p2. Okay, I'm typing fast. There are some errors. Okay, I'll go back to modify it. Don't worry. Okay. Okay, as you can see here, you do have an arrow pointing to here, meaning that test point using the point or testing the point. So this is the use relationship. Okay. So test point use the P1. You do use the P1. Okay, so you use the P1 as the data type, and you create 2 points, and then you print the data. So you print those 2 data. Okay, 2 point data, we get it. Okay, now this is the main program, but this one is a static program, right? This one is a static program. So if right here, I create another one, this one that just call it test main, a test program to test the test main again. This is weird, right? This is weird. Okay, let's actually do this. What I want to do is that I want to run what? Run the main program, this main program in test point. But I'm running this static program in my test main. So this one will be running the program right here. And this one testing the point class defined here. So because this one is a static function, main is a static function. So right here, I can use test point.main. Okay, but because test point.main right here, you do have what? You do have a string array, right? You do have a string. So this is not okay. You have to do new string array empty. So you feed in a empty string array to that function and you run, you will be able to run it. So that's the way you run a class function from a different class. This is class function. So this is a class function belong to test point class. So you do test point.main, you test that main function right there. Any question?
No.
So this one is a point function, point class. It's a pure data class. But now, how about let me copy this tester, put it right here. So here, let me print different thing. Okay, so this one, let's see. If I run this test point, it will call this main function. And then you say, I'm in test point, and then print that 2 point, right? If I run this point, if I run this one from the point class may also have a static function. And then it actually is running this one, not the one in test point. So when you run this one, you will get I'm in point class because I'm running this version, even though the 2 code is the same, except that I print out different things. Is that okay?
Yeah.
So what I want to say is your point class do have a main function, and that main function do self-testing. Okay. You can also have a test main to test this point class, but the main function defined in your test main. Okay. And you may again have a test main to run the main program in the test main. That's another one that we talk about. So class function, static functions are class functions. And class function can be run if you run the class name dot function name. Is that okay?
Yeah.
Okay. Okay, let's actually try another one. So right here, we do have a point class. This one is a toString function, right? Let's actually try, let's do this. Let's try here, let's actually do a function. Let's call it public double. ABS, okay? ABS is this XY's absolute value. Let's assume that it's actually called square root X plus square root Y, okay? Now we need to create square root plus X square root Y. So we do use return math.sqrt. Sqrt is square root, okay? Square root of what? Square root of your double X. This one means x raised to the power 2 or x times x. This one means y raised to the power 2 or y times y. So your square root of x square root of y is square root of x squared plus square root of y squared. This is the absolute value for the point. Is that okay?
Yeah.
But this one do not have static. It doesn't have static, so it actually is an instance method. Instance method means it belongs to the object, belongs to the point. What does this mean? This means that, okay, right here, I can print system.out.print time. Okay, let's do printf. The ABS of P1 equals percentage F comma, then P1.abs. So this one I call the ABS function of P1. P1 is a point. So I calculate the ABS of this point, P1's point. P1 has the absolute value. So P2 also have its absolute value. So each point have its own absolute value. And we can use P1.abs and P2.abs to call it. So both of these are so-called instance method. Instance method is a function belonging to the object, belonging to the point. Any questions so far?
No.
No? Leo, is that okay? Yeah. Is that okay?
Yeah.
So this is a so-called instance method. So basically you have a point, and this point you create a P1 and you create a P2. So P1 has its own ABS value. P2 also has its ABS value. This kind of function we call it the so-called instance method. The method or the function belonging to the object, belonging to the point. Okay. And class method is different. Class method, that's actually right here. Let's actually put another class method. So here, this one, we do not have a static. Let's put someone with a static. Let's call it, let's see, public. Static distance. Point P1, point P2. So give me 2 points. I'm going to calculate the distance between these 2 points, P1 and P2. So I'm going to get a double dx equals P1 dot x minus P2 dot x. Okay, double dy equals P1 dot y minus P2 dot y. Okay, so I got dx and dy, and then the distance between these will be mass the square root of dx times dx plus dy times dy. Okay, you got 0.1 and 0.2. You got x1, y1, x2, y2. The distance is delta x squared times delta y plus delta y squared, x squared. Is that okay?
Yeah.
Okay, but this one is actually calculating the distance between these 2 points. But this function distance, does it belong to P1 or belong to P2? No, it doesn't belong to anyone. it belongs to the class. So this is a class method. Class method belongs to the class, so we use a static. Instance method, no static, it belongs to the point. So basically, you have a point class, you create P1 point, P2 point, your P1 has its absolute value, your P2 also has ABS value. These two functions belong to the point 1 and point 2 respectively. So you do not have static. These are instance method. If you don't have static, it's instance method. As a method belong to the object. If you do have a static, then that function belong to the class. The distance function belong to the class. This is a service routine to calculate the distance between P1 and P2. It provides a utility to calculate the distance between 2 points, but it doesn't belong to any specific point. Is that okay?
Mm-hmm.
So how to use it? Let's go to the test point. Right here, you calculate the absolute value is like this, okay? But you do want to print system.out.print line, print f the distance between P1 and the P2 is percentage f n. Here you do point that distance is the service routine belonging to the point class to calculate the P1 point and P2 points distance. So this object that function name, that's instance method. Object method. This is the class that function name that belong to the class. So class always capital. Object always lowercase, lower camel case. Is that okay?
Yeah.
Okay, let's compile and run. So this is the first time we talk about the difference between the so-called class function and instance function, okay? Class function belong to the class. Instance function belong to the object, okay? Anyway, character that is later belong to the class. It's a character class the function that you can use. You will check whether a later is a later or not, okay? Let's try this. Okay, let's try this. Let's try. Okay, let's try these test characters. So I try from 0 to FF. Okay. Okay, so I go from 0, down to FF. So check every letter whether it is a letter or not. Okay, this one is wrong. Okay, so some of later doesn't show, it doesn't have a symbol, but it's okay. But right here, these are not, numbers are not, okay, numbers are not, okay, and then you start to go into ABC, yes, ABC are letters, yes. And then you go into some symbols again, and then they are not, and then you go to lowercase ABC, that's true, okay, again. So the function is able to detect whether you are later alphabet or not. Okay. Anyway, these are some letters you see. Actually, some European letters they are considered to be later as well. Okay, so be careful. European letters are also letters. Okay. Any question?
No.
Now let's copy one more time. Try one more. So here I don't test it is later or not. Let's test its digit. So there's a digit, okay? And then it's digit. So it's digit right here. Let's see, it's digit. Okay, character is digit. Let's go to the 1, 2, 3, 4 part. Yes, 1, 2, 3, 4. This part you got digit. Others are not. Okay, others are not. So you have its later is digit. You also have its later or digit. Okay, there are many functions. So right here, I just give you the idea of what they are. But these are Boolean methods. They are methods that you can test for its later, its lowercase, its uppercase, its digit, its or later or digit. Okay, different things that you can use. Just give you the idea when you need to test those letters. There are some homework that you may need this. Okay, so that's why I'm covering this right now. Some of the homework problem you will need to have that. So logic operator, you have the and, or, and the not. Any question? Any question?
No.
And the inclusive or, okay? So let's see. Inclusive or is not covered in Java, in AP exam, okay? But you need to know anyway. But it is equivalent to not equal, okay? Not equal. So let's see. So this, sometimes we use the exclamation mark, sometimes we use a bar on top of it, sometimes we use this one, sometimes we use minus A. This all means negation of A. So A is true, then negation of A, not A, we call it not A will be false, okay? A is false, not A will be true. So this one is negation, okay? This one is exclamation mark. Second one is you do have and or, okay? And happen when only both of them are true, you are true. For or when both are for, when one of them are true, you are true, okay? Any questions so far? And there's another one called A capital B. That's inclusive or, that's actually false. This one will be false. And then this one will be true. This one true. This one false. So this means that one of them is true, you will get it to be true. This one's inclusive, is equivalent to not equal. Okay? Any question?
No.
No, this part we just go through it, okay? Okay, so that's Boolean. We talk about Boolean and some characters. And character you declare as char is using UTF Unicode 16-bit format. And you write A like this, it means it's 0x0041. Okay, these are the hexadecimal format. Or you write as this is the same. Okay. As a character. So you can use it for arithmetic. Okay, you can use it. It's an unsigned integer, so you can use it for arithmetic. And the table you need to remember. I think this part we covered it before, so we just go through it. Now here, key point is you need to know about equals function. Is digit is later, is digit or later, is lowercase, is uppercase, to lower case to uppercase. It's different functions, okay? I think these are very easy to understand, but remember to lowercase, uppercase, these are all capital, okay? To letter or digit, okay, these are uppercase. Must remember this table, okay? This is very important. So when you do, can you create an object? Okay, this one actually is a replica. Okay, next one we are going to talk about replicas. What is replicas? When you have integer int a equals 3, you just put a 3 in the variable a, but can you do a but something to do something? No, you cannot, because a is not an object. It is a primitive data type. So there is no function that a can do anything. Same thing for char. You say char equal a equals this low uppercase a later. Can you do a that is later? No, there's no such function. You have to use a class function called character that is class, is later. Okay, so this is a character class, provide function to provide services to the characters. So this kind of classes that provide function to service the data, we call it replica class. Okay, we call it replica class. So that's the one very famous replica class, integer. So right here, we do have integer a equals 3. But can you convert this a to a string? This one, yes or no? Okay, basically, there is no to-string method for int type because integer is not an object. Because it's not a class, it's not an object, so you cannot have method that can convert this integer to a string. That's impossible. Okay. So what can we do? We can do this. We can do integer AW equals new integer A. So wrap up A into a object called AW. So AW has the same value as A, but it also has methods. So you can do printing now. You can do system.out.print line AW.toString. Okay. So basically you have an integer A equals 3. You write it up with the integer object. That's called AW. AW can convert it to a string. Is that okay? Is that okay?
Yeah.
Can AW go back to an integer? Yes. If you want to convert the AW back to an integer, that's also fine. So you want to convert, so here that's again, convert string back to integer. So integer b equals integer that parse int AW parsing the string in integer format. So you read a string. So here you may have string 3. You translate it into an integer. This one must be it's actually parsing it. Okay. ToString. That's actually. No, let's do this. Okay, I'm sorry. Here, let's do string. AS equals AW.toString. So this is a string. Okay, I'm sorry. So let's convert a string back to a integer b. Okay. That's one way you can convert it back to integer. Another way is you can do integer c equals integer that, let's see, no, AW that in value. No, I'm sorry. This one should be integer that value of AS. Okay, let's actually summarize a little bit. Let's summarize a little bit. Does it have a integer a equals 3? You do have an a stored with 3, right? You convert it to an object you say integer AW equals new integer A. It's kind of wrapping up this whole thing into an object with AW. So originally the black one do not have method. Now AW have a method. So you can convert it to string using toString function called AW.toString. You will convert it to a string. Or you can use okay. Let's say you convert it to a string. And then you want to convert a string back to a integer. You use integer parse. Parse is translate. Parse int of the AS. Okay, that's so this string is called AS. Or there's another way you can use the integer that value of AS. These two ways you can convert it back to integer. Okay. So what we are talking about here is how to convert integer to string and string to integer. Okay, and there's another way you can convert a integer to string. You just do double quote plus 3. That will also convert your integer to a string. Okay, this you also use double quote plus. Any question? These are conversion of the data type, okay?
Okay.
So integer is a data type that come with the object and give you the message. And int don't have the object, don't have the message. Same thing for character. Character class is the wrapper class for char. Okay, char do not have method. So right here you have a character object B, okay, and then B compared to A object, it will be B minus A, you got 1, because B is 1 greater than A. So if B compared to B is B minus B, you got 0. Okay, this is 0. If you B compared to C is B minus C, you got -1. Okay, this you can. So this compared to is using the minus sign. First one minus the second one. Okay, compared to function always minus. Equals to check whether they are equal or not. Okay, so character B equals new character B, that's true. Character B equals character D, that's false. Okay. Any questions so far?
No.
Okay, so this different character function you need to remember, okay? Now let's do this, okay? Let's actually look on one problem. Okay, let's say this is a student class. You must remember those scanner, those kind of things, okay? Don't just when you need it and you cannot use it, that's wrong, okay? That's not okay. Screenwriter, the same thing, you have to make sure you really understand it. So system.in is the keyboard, okay? And then we start to enter something, okay, we start to enter something. So let's see. Okay, enter student's name. So here you do input the next. Okay, this one you have to be careful. You type Eric Chow Junior Doctor, whatever, a lot of long name. But only Eric is taken because the first token being taken. The rest of them not taken because you are using the next function. Next function is next token. Okay, token last time we talked about it, actually the next word. You only take one word. So this is may or may not be the right thing that you want to do. Okay. If you want to take the whole name, you have to use the next line. Then that's taking the whole name. Okay, you cannot use next. Use next will only be the one token. Okay, now the whole scene, whatever title you have, all included in the student name. Because next line is waiting for you to hit return. The return mark will be used to determine the end of the next line. Line need to see a return mark. Next, no, next just need to read one word. Is that okay?
Yeah.
Okay. But here come a problem. Here come a problem. Okay, here let's see. Here it come a problem. So if for some reason you do enter student's age, you do integer age equals input, but next integer is that okay? Look like makes sense, right? You actually enter your age and then enter your name. Look like okay, but it's not okay. It's not okay because let's print it out. Okay, let's print it out. That's print it out. It is look like okay, but it's really not okay. Where's my name? I don't have a name, but it actually passed through. What happened is this one called input fit through problem. So this input fit through problem will happen. When will it happen? This not only happen in Java, but also happen in C language, C++ language. Okay. This happen when you actually right here, you do next integer. Okay, you hit the 13 and then return. Right? So right here you do input next line. So it say input next line. So this one got used by the next line. So it got a return. So the name become empty string. Because the next line use the return mark. already. Is that okay?
Wait, so
Let me explain one more time. Is that okay? So let's do it one more time. Here you do have an age 13, you hit return, right? You hit return, you are supposed to enter this next integer to this age, right? Okay, that part is okay. Your 13 got read and then print out right here. There's no problem. Next one, you have the next line. Your next line not waiting for you to input, but they will consume the return mark right here. This is the next line they read. So it got this one and then fits through here. And then the name become empty. Is that okay?
yeah,
Any question?
no.
No? So this is one problem, okay? This is student is one problem. Let's copy this one to student two. So how to solve this problem then? There are two ways you can solve the problem, okay? One way, okay, right here, let's put the scanner in. So right here, next integer, how about this? How about right here? I put a input the next line. So this one consuming the extra new line mark. So that means I enter 13 return, right? This is 13 will be read by the next integer. The return will be read by the input next line. But the input next line assigning to nobody. So this one got consumed. This one got consumed, and then you will come to the next line. It will ask for the name, and then you will ask for the new line. So that will work. So this one will work. You see, this time it allow me to put my name in. Okay? This is called input fit through. Okay, another way to solve this problem is, let's look at student 3. This look like stupid because you need to consume it. Doesn't make sense. So how about this? How about here we do use input that next line. We do read in a string, and then that string we convert it to a integer. Can that work? Yes, it would work. So this one, you will enter 13 and enter as a whole thing into a string. Then this string got parsed by integer again. The 13 is ready. That will work. That will not have that fit through problem. Okay. Any question? Any questions so far?
No.
Must understand this, okay? I just talk about this once. I don't talk about it too many times, okay? Because this is a little bit very complicated. Remember, you can use a past integer, okay? Okay, so that is the past integers function. Next one, we are moving to the mass and number class. So number class, you have double, long, float, integer, short, whatever. We only test on these two, okay? But that's a number class. Number class, you have Rebel class and the regular primitive numbers. And there's another class called mass class. Mass class is a utility class that including all the functions that needed for your math operations. Okay, so this one including the important trigonometry methods, exponent methods, service routine methods, rounding, maximum, minimum, absolute value, random methods. Okay, so important thing is master pi, master e, master. Okay, integer, the mean value and max value, these two are defined in integer class. These are the maximum integer that you can use and minimum integer that you can use. Sometimes we will use it. Okay, remember. Later we will talk about it, but not right now. Okay, and they are also double maximum integer, minimum integer. Okay. Okay, these are constants. You need to remember constants, and these constants are all static, all class variables. So you can do class name dot number. Okay, class name dot variable to get it. And these are different functions. What you need to remember is the max function, minimum function, absolute function, and random function. Okay, these four you need. Rounding function, you have round to the ceiling, round to the floor, rounding, and round to the integer. Rounding is a regular rounding, that's no problem. Okay. Ceiling is to the so-called least greatest integer. Okay, least integer. So the number that is greater than the number but integer. Full number will be truncation to the number that actually is the largest one, largest integer that's smaller than it. Okay, so this is a ceiling function and flow function. So ceiling function, flow function is the same as you do integer x. Rounding function is the same as you do integer x plus 0.5. Okay. Random function will generate a random number between 0 and 1, but not including 1. Okay. So you'll be 0.0000 up to 0.9999999. Okay, these are the random number you will get. But we'll teach you how to generate a random number later, okay, using this master random function. And then important function including power function. Power function, you have power AB, that's actually A raised to the power B, okay. Square root of X. These two functions are more commonly used in exams. And to radian, to degree, sine, cosine, tangent, arccosine, arcsine, arctangent. Okay. Some of you may not learn the trigonometry yet. So, but let me check. Okay, let me check. This one, let me ask someone who may know, may not know. Okay. Instant, let me ask you. What is radian? What is degree?
Radian is like a length. It's like a unit to measure like it's like radius is like a random number that we invented to like measure angles, and radian is like the length of the segment of the angle.
So we have a circle. Why we call this one 90 degree for degree, and why we call it half pi.
It's 90 degrees because we said that degrees would be 360, like a whole circle would be 360 degrees. And radian
Why
is
don't
just,
you call 400? Why you
oh,
use a
it
360?
was just it's just a number we came up with. I don't know.
How about Leo? Why we don't use a 400? Right? You can use 100 for a quadrant. Why 90 as a quadrant? These are questions, okay? Okay, in the ancient days, the sun go around the earth, okay? They believe the sun go around the earth, not earth goes around the sun. Sun go around the earth 1 year. Actually, it's actually 365 days, but they kind of very rough, so they come up with the 360 days. So a circle, they mark every day how much the sun changed locations. It end up with 360 days. So each one of them is 1 day. Is that okay? So it coming from the sundial. Is that okay?
Yeah.
Then why 90 degree? Not half a pi. How this radian is defined?
Radian is like if you have like a circle
Mhm.
and then this is the radius. So
Yeah. But
the radius and
why
this is the radius.
why we say it actually 90 degree is half pi? Why we don't call it a whole pi?
Um,
Stephen, do you know?
Not sure.
Not sure. It's okay. If you never learn, it's okay. How about Leo? Do you know? Why this one 90 degree, we call it half a pi. And sometimes we call it 90 degrees. So in math, the math teacher always could tell you, oh, 90 degrees is a half a pi. Then why is so? Why don't you define it as 2 pi or 3 pi or 4 pi, and why it's actually half a pi?
Oh, wait, is it because you convert 90 degrees to radian? It would become pi over 2.
I know, but why? My question is why? The fundamental reason why you define the 90 degree as half pi. How about Leo? You probably take a calculus before, so you may know. How about Brenda? Do you know?
I'm not too sure.
Okay, it's very simple, okay? Because we are defining the circle in unit circle. You heard of the word called unit circle before, right?
yeah.
So unit circle is a circle with a radius of 1. Okay. So radius of 1, this is radius 1. So when this radius of 1 make a circle, how much is it for the whole circle?
2 pi.
2 pi, yes. So this one, arc, is arc. If this one is theta, this one is R. The length of this one, the arc called S will equals r times theta. So when this r is 1, this is theta is half pi. Then your 90 degree, the arc of the 90 degree, this one, from here to here, the green one's length is half pi. So the radian really is the arc length of your unit circle. Is that okay? So if we want to calculate a length of this one, same theta, but here you have the R2, then your this length over here will be R2 times theta. The theta is the angle, is the ratio between your unit circle and the pie chart. So half pi means on the unit circle, this 90 degree, the arc will be half pi. The arc length will be half pi. Okay? So when you have a pi like this one is r, the base is r theta, right? What is the area of this fin? Is half of the base r theta times r. It actually is equal to half r squared theta. Okay, so when theta equals 2 pi, what will happen? It will be the whole circle, the area will be pi r squared. Is that okay? So you can treat it the fin type just like your triangle. Your r theta in the arc times the base times the height. Your radius, half of the r theta times r, actually you will get your area. Okay, this is very important in physics. Okay, in physics, this is extremely important. You must know about trigonometry and this. We are not teaching you physics, okay, but we are teaching you fundamental calculation. Later, when we go to, if we need to do using Java for mathematical calculation, area, or use for physics modeling, you will need it, okay? Any question?
No.
So radian is the arc length on the unit circle, okay? Anyway. Let me take a picture. That's why you usually have degree, okay? Degree tell you is actually human, usually how many days on the sundial you can actually know that where it is. But the real length that you are using actually is in the radian, in radian. Okay, so radian and degree, you need to know how to do conversion. And then there is a sine function, cosine function, tangent function. When we have time, we have covered it, but not right now. And you need to know about sine's law, okay? And this one cosine law, okay, cosine law. You need to remember this cosine law. A squared equals b squared plus c squared minus 2bc times cosine A. A is the angle, okay? Cosine law. Okay, next one is random class. So we talked about the math class. Math class is a collection of functions, and there are some homework you need to work on, okay, to practice these different functions, making sure you know how to call them, okay? Maximum function, minimum function, absolute function, ceiling function, random function, okay? These different functions, power function. Then you need to do the homework. And then next one is a random class. Okay, we'll talk about random class. Random class and match.random function. Random class was in AP exam before, but it was taken out. Okay, it was taken out. Today we still will actually do it. Okay, we'll still do it, but it's not tested. So this random class, let's look at the inputs. Random class you use when you need to do simulations. Okay, you need to do simulations. So let's look at the regular input. So regular input, you have a scanner input equals new scanner system.in, okay, something like that, and then let's do for integer I equals 0, I let's spreadsheet I increase, okay, do 3 times, and then let's do system.out.bring, okay, and then enter your age, okay, you have the integer age equals 0, okay. Oh no, let's see. I'm sorry, here let's put a sum, okay. And here let's do integer age equal input next integer, okay, and then sum plus equals age, okay. Okay, this one, we try to get 3 input as the input of people's age, okay? So now you actually kind of run it. So you enter your age 3, 4, 5, okay? And then you got the total age, that's okay. But now, this one is because you use a keyboard input, right? But sometimes you may want to use a random number generator to generate it. Because I don't want to key in, I want to use a random number generator to generate it. How can I do it? So here I'm going to create another one called random inputs. Okay, so this one is from the utility class. So you need to import the java.utility.random. Okay, you need to do that. So regularly you do scanner like this, okay. So right here you bypass it. You say random R input equals new random. Okay, so here you no longer have a keyboard input. Okay, and you are using random input, so you basically do not need to tell people what it is. So no need for this. And then right here you do input integer A equals R input. Next integer. This next integer right here, you are going to create something called 100. Because it's the age, you will create a number from 0 to 100, but not including 100. So it will be 0 to 99 for the age. So what I want to say is random class is used very similar to scanner class. Scanner class is an input string from keyboard. This random class is an input string from random number generator. Is that okay? That's wrong. And you will generate 3 random number for you. Okay, total 119. Is that okay? Let me print each one out, okay? Let me print each one out. We get the A and then we do system.out of the 9. Each age, we will have to print it out, okay? Okay? This number, this one from keyboard, there's no number in here, okay? This one from random number, it has the next 100 because you need to know about the range. So right here, you can check like Java random class. Okay. And this Java random class right here, they'll tell you what function you have. They are input string, integer string, so you can generate next Boolean, next byte, next double, next float, next Gaussian, next integer, okay? Is that okay? Any question? Just like you are using the so-called, keyboard input. Is that okay so far?
Yep.
Yeah.
Let me repeat one more time. Your regular input is you set up a keyboard like this, scanner input, new scanner. Your random input is random R input is random input equals new random, nothing in here, okay? This is random class. Let's try another one, okay? Let's try random double. Okay, random double. Okay, let's assume that we are going to calculate the random GPA for 100 students, okay? So we do random R input equals new random. Okay, creating a random input string. Okay, after that, you actually do for integer I equals 0, I less than 100. I increase, you calculate the random GPA for 100 people. So here you have the integer, let's call couple, okay, total. Right, and then you do couple GPA equals R input and next couple. This one will create a number between 0 to 1, but not including 1. So that's not your GPA, you need to find 4.0. That will move to from 0 to 4.0, but not including 4.0. So it's up to 3.9999999 something. Okay, but anyway, that's close enough. So let's do total plus equal GPA. Okay. And then double average. Over divided by 100. Okay. So this one from 0 to 4.0, wrong. But not including 4.0. Okay, anyway, it's low. It's a random number. Oh, this one should time 4. I'm sorry, here I forget to time 4. Because you're generating from 0 to 1, you need to time 4 to become from 0 to 4.0. Okay, any question?
No.
So this one is to use the random class. Okay, so random class can be used like a little bit like a scanner. Okay, now we are going to go over to the another function called master random. Okay, we are going to go over master random. So this is a random class a little bit too complicated. Every time you need to create a input stream. Okay, so we may not like it. So let's do random double 2. We will generate a random number, but we don't like to use the random. Random class is okay. It actually can be used to generate a lot of numbers, but sometimes it's a little bit too complicated. We don't like to use it every time. So get rid of the random. We don't need the random. So here, do not use this one. Do not use the random input. We just use master random. So this random is the same as R input the next double. The 2 is the same. Except this one do not need a random class. It doesn't need a random class. It uses a master random. So these 2 are the same. Okay, so here master random provide the same result as R input the next double. Okay, but we teach you next double first because you know that it's similar to the input. Okay. Other than that, it's the same. Let's put it over here. So this layout, you can save it here. Then this time you keep popping up at the same location. Any questions so far?
No.
Okay. So this one is from 0 to 3.9999999. How about if I want to include 4? What can I do? If I want to have a GPL 4.0, I don't want to miss out a GPL 4. What can I do? This one random 2 only go up to 3.99999 because it says from 0 to this, right? Now, if you want to go to 4, there's one way you can do it. Here, you do final static double E equals 10 to the power minus 9. This is a very, very tiny number. Tiny number. Okay. So this one actually plus E. Plus the E is error. Okay, E is error. So you plus a little bit of the E. So it actually is 0 plus E is a 4.E. Okay. So this one is a 4.E, not including 4.E. So it's slightly over 4. It's a 1 to the 1 nano over 4. It's 1 nano over 4, but we want to include 4, so we can do this. Okay, let's do this. Okay. So while GPA greater than 4.0, GPA equals next random times 4.0 plus E. We do it again. We'll do it again because here you get a E, it may be 3.2, maybe 4.00001. If you go to here, you are slightly over 4. Then you get a new one. You get a new one. You get a new one. When will you finish and get out of while loop until your GPA is less than or equal to 4.0? So when you get out this while loop, the GPA guarantee is under or equal to 4. So this one, the guarantee is from 0 to 4.0. Does that make sense? Slightly over, the chance is very low. So you while loop keep doing it, the chance is very low. And if you get out of while loop, your GPA will be less than or equal to 4. That's what we want to have. Any question?
No.
This one is to exactly get a value of 4, up to 4, okay? The random double 2 is up to 3.99999. Okay. Anyway, these are technique to get a random number. Okay, there are some problem, you can work on it, okay? And then this basic API, we talked about it already. So this chapter's main purpose is to know about the environment, to know about what library you have, to know about the different things that you covered, okay? So this Java.util or random scanner, this AP don't test it, but very important. It's important, but AP will not test it. This Java language that string builder, this also AP test this one, this one, this one, this one, this one, this one. Okay, but all very important. You all need to know about these different classes. System.out is your monitor. Okay, so it's an object by itself. Printwriter is the you can set up to the output file. Okay, last time we talked about it. Okay. Scanner is to set up the keyboard input. Okay. Okay. Anyway, we are done with the chapter. Any questions so far?
No.
And then please work on the homework. Okay. And one more thing, let me actually emphasize one more time. This course is very important. It will lead you to competitive programming, okay? So do not skip too many courses. Do not forget to submit homework. Do not actually try to, you must understand every single statement that we teach, okay? If you don't understand it or you forget it, and then you come back to the competition and you kind of, hey, what happened to this? I don't remember. Then that's not okay. That's not okay because at the competition time, you don't have time to learn things, okay? You have to remember everything right away, okay? Is that okay?
Yeah.
And then one more thing. Here, if you want to go to engineering school, not only the computer science, but also engineering school, you all need this computer science course, okay? You all need this AP computer science. It's a fundamental course now for every engineering student to learn AP CSA. And then beyond that, the computer science core courses, you may or may not need it if you are not CS major, but this is CSA course. Even if you just an engineering student, you will need it, okay? You will need it. It's a basic programming requirement now, okay? So we are teaching you this portion and moving to here. So if you are not done with the solo, then please speed up, okay? And then if you are in the coding bed, making sure that you actually practice each problem 2 times, 3 times, okay, using different method, okay. We discuss with you for different way to write it. You need to remember and compare, okay? Not just, oh, I get a job done, I'm okay, I'm fine. No, it's not enough. You have to know about which is a better method, why we are doing this, why we don't do this, okay? Same thing for those mathematics. Later, you may need those calculus in machine learning, in data science, in statistics, in neural network, okay? You may need those trigonometry. You just don't know. Someday you will need it, okay? Okay, if no question, that's it for today, okay? See you next time. Good night and bye-bye.
Thank you.
Thank you.
Bye-bye.